Let's continue with 1.3b, where we're looking at problems that have to be, um, where we need to include algebraic methods to be able to find the limit of an expression or evaluate the limit at a point. So let me recap the steps. The first thing that we do is we always evaluate the argument first. Sometimes we may look at a problem and just instantly think that we know what the step is. But I think it's just a good habit for us to always take this step first. Let's just plug in that value, even if we feel like we know what's going to happen. Let's just do that first. Um, uh, so if we plug in and if we get a real number, then that's the end of the problem. There's nothing more to do from there. However, we're expecting most of the problems that we're going to see to be something in the form of 0 over 0. Okay, 0 over 0 is indeterminate form. This means that the point doesn't exist, however the limit does. So indeterminate form means that there's a hole in the graph. We have to do further work to get to our answer. It's kind of at an incomplete stage when we see 0 over 0. So we've seen problems where we have to factor on that first day, and then this previous page, we learned that we have to work with problems involving conjugate method when we see radicals, and when we see complex fraction to find common denominators. But either way, we're trying to get that numerator to clean up to be a version of the denominator in the sense that we can find the common factor to reduce and reevaluate. So once we have our reduced expression, after we've canceled out the whole, we're going to reevaluate the limit, and then we'll confirm that the resulting evaluation is a real number. So I'm going to walk through these problems here. These are already done. So example, problem number 1, we plug 4 in, and we get 2 minus 2 over 4 minus 4. I put arrow 0 over 0. So this indicates that this is indeterminate form. The limit does exist, but right now in this current form, we're unable to make any conclusions. So we see a radical. So I'm going to find the conjugate to multiply with this numerator expression. So the conjugate term is going to be root x plus 2. Right? I'm just going to make a copy of what I see here. The only thing I'm changing is the sign in between. And whatever I do, I'm going to make an exact copy here. So that's something that I've seen in the past where some students would put a plus 2 and a minus 2 here. So once we created the conjugate, we're going to make it a duplicate version above and below. Okay, we're not going to change anything to a minus after we've already found the conjugate. So make sure these are exact replicas of each other. So once we have that, then we're just going to be expanding the numerator and we're leaving the denominator alone. Okay, the x minus 4 is already ready for us to cancel out. We just have to get the numerator to produce some version of x minus 4. So we don't want to lose this x minus 4. So we're just going to FOIL the numerator. When we FOIL, expand, we're just going to multiply the first pairs and then the last pair. So root x times root x is just x. Negative 2 times 2 is just negative 4. We see x minus 4, common factors are now available for us to cancel out. Remember that there's still a 1 left over. Even after we cancel out, this cancels out to a 1. So as a 1 over root x plus 2, we reevaluate and we get a real number. Root 4 is 2, 2 plus 2 is 4, so 1/4. All right, number 2, we see a complex fraction here. So I'm probably going to be finding common denominators, but I'm going to try to not forget about my first step. So plug 0 in for x, I get 1/3 minus 1/3 is 0, 0 over 0. Indeterminate form, we have to continue working. So I'm just going to focus my attention on this numerator portion. I'm going to find a common denominator. My common denominator, the 3 plus x and 3 are not the same, so I need both to create my common denominator. So I need both a 3 and a 3 plus x. Right? Now I'm going to balance each of these fractions. This 3 plus x is different from this 3 and 3 plus 3 times 3 plus x. The difference is that this 3 plus x is missing that 3. So I need to multiply the numerator by 3, and that's what I did here. Second fraction, this 3 and this 3 times 3 plus x, these are different by a factor of 3 plus x. So I'm going to multiply the top by 3 plus x to balance this fraction. So I get 3 plus x over 3 plus x. All right, so I'm going to combine these fractions together. Now that I have a common denominator, I can push this together to be the same fraction. And when I do that, I get 3 minus, now here's something we've got to be careful about. This negative is going to distribute to both these terms. So you may want to put this in a set of parentheses as a reminder that this negative has to distribute through, change both of these signs, 3 minus x. Okay, so now that this is under one fraction, we don't want to forget about this x that is still part of our problem. And we now want to push this to the top so that we can find a way to match and cancel out further. So I'm going to multiply by the reciprocal of x, which is 1 over x. Whatever I multiplied to one side of the fraction, I can also multiply to the other side of the fraction. So now that this goes away, 3 minus x is just going to be negative x, and this x is going to cancel out. And we're left with negative 1 over 3 times 3 plus x. The whole has been removed, and now it's just a matter of reevaluating, replace 0, and for x, we get negative 1 over 3 times 3, which is negative 1 over 9. All right, number 3. First things first, let's plug in 0, and for the x's, we get 0 minus 0 over 0. This is an indeterminate form. Indeterminate form tells us it's an incomplete problem. There's a hole, and we have to do the work to find that hole, remove it, and reevaluate so that we can get to the limit. So I can do some GCF from the numerator. I can take out an x squared up top. I'm left with x squared minus 5. Now it becomes apparent that the x squared is what we can remove. We can remove these pieces here. We're left with this just x squared minus 5. Reevaluate, we get 0 minus 5, which is negative 5. All right, number 4. I see a conjugate, but I'm not going to skip the first step. I'm going to plug in 16 in for x. So 4 minus root 16 is 4 minus 4. 16 minus 16 is 0, so 0 over 0. Indeterminate form. I see a radical. I know that this x minus 16 is what I want to appear in the numerator in some form or another. So we're going to use the conjugate method to help us hopefully get that to appear. So multiply the numerator and denominator by the conjugate. First, I need to identify the conjugate. So 4 minus root x is the original expression. My conjugate expression is the 4 plus root x. Whatever I identify as the conjugate, I'm going to make a duplicate below. Now I'm going to FOIL expand this out. So if I expand this out, I get 16 minus x. The denominator, leave this alone. We don't want to expand this out. If we expand it out, we lose sight of this x minus 16, and this is already in a place for us to cancel out. So we don't want to lose that x minus 16. Now, if we see we're able to clean up the numerator nicely to be 16 minus x, but it's not quite perfect, right? It's off by a factor of -1. So I'm going to factor a -1 out without changing the expression. So if I take -1 out, I can change the sign of the x and the 16. So I get -1 times x minus 16. Now I have a perfect match. Cancels out. The -1 stays. I get -1 over 4 plus root x. Reevaluate the expression. So -1 over 4 plus root 16. 4 plus 4 is 8. -1 over 8. All right, number 5. Plug in 4 into the expression. We get 0 over 0. We know that there's a hole. This is just going to be a factoring problem. So I'm just going to look to factor the numerator and denominator. Multiplies to be -44, adds up to be 7. That's going to be 11 and -4. Multiplies to be 8, adds up to be -6. That's going to be -4 and -2. I conveniently see the cause of the 0 over 0s. I can remove them and then reevaluate and I get my real number answer. All right, number 6. Plug in 0, we get 1 plus 0, which is root 1. Root 1 is which is 1. 1 minus 1 is 0. 0 over 0. So we know that there's a hole in the graph. We see a radical in the numerator. We're going to approach this using the conjugate method. So I'm going to copy what I see here, both these terms, but the only thing I'm going to change is that minus sign. Change that to a positive, but I'm not going to touch this sign here. This is going to stay as a plus inside the radical. So 1 plus 2x plus 1, and then copy this below, right? Because whatever we multiply by the numerator, we need to multiply by the denominator. Otherwise, we're changing the expression. All right, so we're going to expand. This becomes 1 plus 2x minus 1. Denominator we leave alone, right? We don't want to expand the denominator. 1 minus 1 is 0. We get 2x over 3x. Now, the 2 and 3 are not going to cancel out, but the x's will. So we take the x's out. We're left with 2 over 3. Root 1 plus 2x plus 1. The whole has been removed. We reevaluate, and we get 2 over 3 times 1 plus 1. 1 plus 1 is 2. 2 6, the same thing as 1/3. So that's our answer. All right, number 7. Again, we see a complex fraction. We're going to see a similar problem as we did number 2. So we get 0 over 0. This tells us to move forward with our cleanup process. So again, I found my common denominators is 4 and x minus 4. I balanced the numerator as well. So x minus 4 goes here, a 4 goes here. I want to merge these two fractions together. So I get x minus 4 plus 4, which is just going to be x. And now that I have my two fractions combined to be one fraction, I'm going to bring this denominator up by multiplying by the reciprocal. So x times 1 over x times 1 over x. X's cancel out. The 4's cancel out here. The x's cancel out. I'm just left with 1 over 4 times x minus 4. Reevaluate. I get 4 times negative 4, which is negative 16. So negative 1 over 16. All right, number 8. Another conjugate problem here. So we plug in 5 in for x. We get 0 over 0. This confirms there's a hole. We're going to continue moving forward with our conjugate method. Multiply by the conjugate. So just going to duplicate what I see here, but I'm just going to change the sign from a minus to a plus. Expand this out. Keep the denominator alone. Okay? We don't want to expand the denominator. However, there is something, though, is that this becomes x minus 5. We can actually do something with this x squared minus 25. We're not foiling this out, but we are going to do a little bit of expansion within this x squared minus 25. So there's a difference of squares there, x minus 5 times x plus 5. Now we can cleanly see where the hole is occurring, where the common factor is occurring. We take those out, and then we reevaluate. There's a 1 left up top. Replace all the x's with 0, so we get 5 plus 5, and this becomes 5 minus 1, which is 4. So root 4 is 2. 2 plus 2 is 4. So 10 times 4 is 40. So 1 over 40.